Good day. I am your host, Mr. Runyan, and this is Unsolved Math Problems, Screencast-O-Matic 2020 edition, Corona. Have you ever wondered about those unsolved math problems? Those ratios on the back of your macaroni box that tell you exactly how much milk to add to your cheesy sauce? Who came up with that? How is it perfect? Today's episode, we're going to dive into that very problem. And hopefully, you might be able to help us out and confess. Yes, you. Let's get to this math problem today. Welcome. Hi. Yeah, we're done. So I'd like you to do the first one. You should have the PDF somewhere near you. Maybe you're not using the PDF, which is completely cool. And then you can just take a picture of your work for me. I'm good with that as well. Just make sure you turn something in so you can get points. And then at the end of this lesson, there is a quiz. So just make sure you take it. Okay, so the first one, if you want to go ahead and pause it and solve this, just write a one-sentence story about a ratio. Can it be a problem about macaroni and cheese? Yes, it absolutely could. Like Mr. Runyan. Put 4 parts milk to 1 part cheesy macaroni powder. And it didn't taste very good. He was only supposed to put 2 parts milk to 1 part macaroni powder. How much more milk did he put than he should have? Or something like that. Yeah, go. Don't use my macaroni one, though. You should have paused it like me right now. Hi, I'm going to unpause. Woof, poof. Weird how I guessed that right. Okay, so you should have your work done. You guys should have written some kind of sentence. And then write the ratio in 2 different forms. If we're going with my crazy one, I would say, 4, good old Mac annotations to 1, or 4 to 1. This is exactly what we've done on our 5-a-day. So you should know how to do this. Okay, this next one's actually kind of a fun problem. Shani and Mel are using a ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon, or Shani, to the length of Mel's ribbon is 7:3. Draw a tape diagram to represent the ratio. Okay, so a couple things that you can do first. That I'll teach you, that I used to teach my 5th graders. First off, you got to know what a tape diagram is. I realize that some of you haven't spent a lot of your math career, your history, your long life, like you're making the tape diagram and you're drawing it out. A tape diagram is simply just a tape diagram. Diagram means picture. Tape, well, I don't know why it's called a tape diagram. We would say, I'm just going to use this cool one here. I've got 1, 2, and 3. There we go, 3. So this one would probably represent Mel's, or whoever the other one was. I don't know which one it would be. I'm going to pause this. It always pauses me. I don't get it. My old 5th grade job never paused like that when I would try to scare. It's not as fun. Okay, well, if we read it again, so the ratio of the length of Shania's ribbon to the length of Mel's is 7:3. So that's telling me that Shania's ribbon is the 7, and Mel's is the 3. We've kind of seen a chart like this on our 5-a-day. If I was going to keep going, Shania's would be 14. Well, then Mel's would be 6. If we kept going, it'd be 21. Ooh, an hourglass or common box. Gotta make sure I do a few circles. And Mel's would be 9. Or an hourglass. I'm gonna leave it. I don't care. I like hourglasses. So that basically tells me that, right? The ratio of the length of Shania's ribbon to length of Mel's ribbon is 7 to 3. 1, 2, 3, 4, 5, 6, 7, 2, 3. So for every 7, Mel has 3. Okay? So if we keep on looking at it, that's it. Told you it's easy. Don't pause me. Pause me again. At least you know when I pause and unpause, I guess, huh? Okay, so let's do a little bit of questions with this. So you've created the tape diagram. What if I told you that one part of Mel's was 2 inches? Could you tell me how many inches Mel's ribbons total is? Yeah, because what do I try to tell you? If you can tell me or find out 1, you can usually find out 2 or 3. If we know that this one is 2, does that change our ratio? Well, yeah, it'd be 6, right? 2, 4, 6. But then how would it change this one? Would it be 14? No, because I'd change the value. That was if it was 1. So if each one of these is 2, what would you get? 2, 4, 6, 8, 10, 12, 14. What? I doubled? So what would the ratio be? Would it be 14 to 6? Or would it be 7 to 3? Today's episode of Unsolved Math Problems. That was the wrong voice. But you get it. Okay? 14 to 6 is the same thing as 7 to 3. The 7 to 3 is just the simplified version of 14 to 6, which we can see there. So if we were going to simplify that fraction or ratio, we'd get 7 to 3. The same thing if I said each value is worth 3, or 3 meters, or 6 meters. 6 times 3 is 18. 7 times 3, is that what I said? No, 6. 6 times 7 is 42, I think. Let's do the next one. All right, I almost said episode. I wish it was episode 2. Man, The Mandalorian, way to go. I really enjoy the Western feel. Like, I feel like I'm watching Westerns with my grandpa again. Exercise 3. Mason and Laney ran laps to train for the long-distance running team. The ratio of the number of laps Mason ran to the number of laps Laney ran was 2 to 3. If Mason ran 4 miles, how far did Laney run? Draw a tape diagram to demonstrate how you found the answer. Go ahead and do it while I pause it and make it, because that's going to take a while. Okay, yep, there I paused again. So I went ahead and did my own tape diagram. All I'm doing is representing 2 places, 2, 3 places. I know that Mason ran to the number of laps was 2 to 3. They're talking about Mason ran to the number of laps Laney ran. So then I know that Mason was 2, Laney was 3. So it says that if Mason runs 4 miles, that means that this whole thing right here is 4. Okay, now I know I did this on the math test. This is how I solved it. But if you do a tape diagram and you see that you have a value of 4 and there's 2 squares there, but the whole thing, remember, we got to start thinking of fractions as a whole. What does it equal? Yeah, the whole thing equals 4. And the fraction of 4, or the whole number of 4, is being divided into 2 parts. So if the 4 is being divided into 2 parts, that means that each part equals 2, or whatever that sign is. 2. So we can also then make the assumption if it's 2 to 3, then these are the exact same. So we can say, oops, I'm just going to copy this one. Yeah, I'll own you. That would be 2. That would be 2, because that would be a 2 to 2, which would be the same ratio, and 2 to 3. So there we go. And we can also always do that over here. This just kind of helps me see it a little bit too, of like a ratio on a chart. Okay, so now if Lanny ran 930 meters, how far did Mason run? Does that really change anything at all? Well, a little bit. Instead of this one down here, we're actually going to bring it up here and flip it. That would be cool. Ooh. We're going to say that this whole one is now equaling 930, or hourglass 30. So again, I have a whole of 3, right? This 930 is being divided into 3 parts. So you need to divide it by 3. Well, 3 goes into 9 3 times. 3 times 3 is 9. I'm just going to do it since there's not a lot of work here. 3 goes into 3 1 time, and that would be a 0. And drop a 0, and 3 goes into 0 0 times. So I would say each one of these equals 310. 310, 310, 310 equals 930. But I have 2 of them. So 310 plus 310 is 620, or hourglass 20. I mean, it's only, yeah, I mean, it makes sense. A 9's up, a 6 is down. They're basically the same number. So why not have an hourglass up and down? Oy vey. Apple annotations, fix this for me. And we basically just did this for B, but I did it on 1. Ooh, there's that guy. Hello, goodbye. What ratios can we say are equivalent to 2/3? I'd like you to pause and solve this. Perfect. You should have paused it. I said pause. Okay, good. You did. You're waiting on me. Okay, so again, we have ratios equal to 2/3. So we're just, I don't know why. I thought I made that a real 2. There we go. How did it get cut off? Oh, I guess I didn't make it a real 2. 2/3. Okay, so we want them to both be the same. So what you do to one side, we're going to have to do to the other. So if I have a 4, right? 2 times 2 is 4. 2 times 3 is 6. 2 times 5 is 10. And 3 times 5 is 15. And then you can keep on going that way. So just make sure that what you do to one, you do to the other. Exercise 4. Josie took a long multiple choice end of year vocabulary test. The ratio of the number of problems Josie got incorrect to the number of problems she got correct is 2 to 9. Or 2:9, as Senor Byerly would say. If Josie missed 8 questions, how many did she get correct? Draw a tape diagram to demonstrate how you found the answer, which of course means I'm going to pause it, and you should pause it and solve it. Okay, I went ahead and created mine. Still don't get why it freezes me. So I went ahead and also marked it as I and C, incorrect to correct, because it says it got incorrect to the total. So it means incorrect to the total of correct. So if you got 2 parts to every 9, incorrect. So if she missed 8 questions, that means, and this is why I wish you guys would start to draw pictures, that means this part right here is 8. Well, if this whole thing is 8, and it's divided into 2 parts, it means each problem is worth 4. And we can make sure that these are the same. So 9 of them, right, times 4 would be 36. How many did she do total? You just have to add it. if she missed 20 questions, how many did she get correct? So you're doing the same thing. So hopefully you've already done it. Maybe you can start to do this mentally. 20 divided by 2 would be 10, right? So each part would be 10, which would mean that the 9 would be 90. Or a mint hourglass. Yeah. All right. What ratios can we say are equivalent to 2 to 9? I'm not going to do that, but you can come up with another possible ratio of the number Josie got incorrect to the number she got correct. And then go ahead and solve it. Make it a little bit challenging. Don't do zeros and don't do ones or twos. Yeah. Okay. You can just maybe ask yourself, how did you find the numbers? Are you doing it mentally, or are you starting to draw the tape diagrams and draw pictures? And do you start to understand that when you draw that diagram, you're representing it to be a whole? And then that whole then is divided into parts. Split, equal, buzzwords for divided. And then how did you create your equivalent ratios? I'm hoping that you're starting to think of keywords as like, what you do to one side, you do to the other. So if you multiply the 2 by 2, then you have to multiply the 9 by 2, because you're just going to expand it so that they are both equal on the same sides. Okay. So I would like, this is basically what's going to be on your quiz. I'm kidding. But I would like you to challenge yourself on these ones as you practice for the quiz. Okay. So do your best. I'm not going to give you the answers for these. I would like you to just work on them yourself. And then as soon as you feel that you are finished with this video, go ahead and take the quiz.